Thank you for watching Edupedia World videos. In this session, we will learn about the part C, that is concurrency control of transaction management. What is concurrency control? When multiple transactions are trying to access the same shareable resource, there could be some problems that may arise if access control is not done properly. There are some important mechanisms to which access control can be maintained. Earlier we have talked about these theoretical concepts like serializability and other things, but the practical concepts of these can be implemented by using locks and timestamps. Here we shall discuss some protocols where locks and the timestamps can be used to provide an environment which is concurrent transactions and that can preserve the consistency and isolation properties of a DBMS. Let us understand about lock-based protocol. When multiple programming are taking place in an environment where multiple transactions are executed simultaneously, there is a high need of controlling the concurrency of the transactions. We have concurrency control protocols to ensure atomicity, isolation, and serializability of concurrent transactions. Concurrency control protocols can be broadly divided into two categories, that is lock-based protocols and timestamps. But let us first review lock-based here. Lock-based protocols. A lock is nothing but a mechanism that tells the DBMS whether a particular data item is being used by any transaction for read or write purpose. Since there are two types of operations, that is read and write, whose basic nature are different, the locks for read and write operation may behave differently. Read operation performed by different transactions on the same data item poses less of a challenge. The value of the data item, if constant, can be read by any number of transactions at any given time. Whereas the write operation is something different. When a transaction writes some value in a data item, the content that data item remains in an inconsistent state for the time that the operation starts till the moment the operation is over. Now, if we allow another transaction to read or write the value of the data item during the other transaction or the other operation whose transaction is not yet over, then there are high chances of encountering an inconsistent value. In both cases, anomalies will creep into the database. So the simple rule for locking can be derived here. If the transaction is reading the content of a shareable data, there is no problem, any number of processes can read. But if any transaction is writing into the shareable data, then there is a need of locking the transaction till the transaction or till that data item is being executed by that particular transaction. DBMS have lock-based protocols to use a mechanism by which any transaction cannot read or write data until it has an appropriate lock on it. Locks can be of two categories: binary lock and shared or exclusive lock. A binary lock is simple, that means it is locked or unlocked, whereas a shared or exclusive lock stands different. If a lock is acquired on a data item to perform a write operation, it is an exclusive lock. If you allow more than one transaction to write on the same data at the same time, it will lead to database inconsistency. Next is simplistic lock protocol. A simplistic lock-based protocol allows transaction to obtain a lock on every object before a write operation is performed. Transaction may unlock the data item after completing the write operation. Next is pre-claiming lock protocol. A pre-claiming lock protocols evaluates their operation and create a list of data items on which they need locks. Before initiating an execution, the transaction requests the system for all the locks it needs beforehand. If all the locks are granted, the transaction executes and releases all the locks when all its operations are over. If all the locks are not granted, the transaction rolls back and waits until all the locks are granted. Here you can see that the transaction begins when all the locks are acquired and the data set is in lock phase. And when the data set has been executed by the transaction, the transaction ends and the dataset is again available for the next transaction. The two-phase locking protocol. The two-phase locking protocol defines the rules of how to acquire the locks on a data item and how to release the locks. The two-phase locking protocols assume that a transaction can only be in one of two phases, either in growing phase or in the shrinking phase. Let us understand about the growing phase. There are two main things that we need to understand. First is transaction may obtain locks. Second is transaction may not release locks. In the phase, the transaction can only acquire locks but cannot release any lock. The transaction enters the growing phase as soon as it acquires the first lock it wants. From now on, it has no option but to keep on acquiring all the locks it would need. It cannot release any of the lock at the phase. Ultimately, the transaction reaches a point where all the lock it has to need has been acquired. This point is called the lock point. Second is the shrinking phase. After the lock point has been reached, the transaction enters the shrinking phase. In this phase, the transaction can only release locks but cannot acquire a new lock. The transaction enters the shrinking phase as soon as it releases the first lock after crossing the lock point. From now on, it has not the option to have the another lock, but it has only option to release the acquired locks. These are two different versions of the two-phase locking protocol. First is strict two-phase locking protocol and another is rigorous two-phase locking protocol. So here we can see the transaction begins when it has all the acquired lock and performs the transaction, or it executes over the data item, and as soon as the data item has been reaching of its end, the lock opens, and this phase is known as the growing phase and this phase is known as the shrinking phase. Next in the concurrency control list is the timestamp based protocols. The most commonly used concurrency protocol is the timestamp based protocol. This protocol uses either the system time or the logical counter as the timestamp. We have seen the log based protocols that manage the order between the conflicting pair among the transaction at the time of execution, whereas the timestamp based protocols start working as soon as the transaction is created. Every transaction has a timestamp associated with it, and the ordering is determined by the age of the transaction. A transaction created at say 2 o'clock time would be older than other transaction that come after it. For example, if the transaction Y entering the system at 4 o'clock is 2 seconds younger, and the priority would be given to the older one. In addition, every data item is given the latest read and write timestamp. That lets the system know when the last read and the write operation was performed on the data item. Timestamp protocol. Timestamp is a tag that can be allotted to any transaction or any data item, which determines a specific time on which the transaction or data item has been activated in any way. It is similar to the concepts of date created and last modified properties of the files and folders that we commonly find in our computers. The timestamp ordering protocol. It ensures serializability among transactions in their conflicting read and write operations. This is responsible of protocol system that the conflicting pair of tasks should be executed according to the timestamp values of the transaction. First is the timestamp of transaction Ti is denoted as Ts, that is timestamp of Ti, transaction I. Read timestamp of data item X is denoted by R dash timestamp X. Then write timestamp of data item X is denoted by W dash timestamp X. In the previous slide, we have seen that a timestamp ordering protocol ensures the serializability among the transaction in their conflict read and write operations. If a transaction Ti issues a read X operation, we have the following two conditions. Either operation will be rejected or the operation will be executed. Operation will be rejected in the case if timestamp of Ti is less than the writing timestamp of X data system or data item. and if the operation has to be executed or accepted, then the timestamp of this transaction should be greater than or equal to the write timestamp of this data set or data item X. Here all the data item timestamps are updated. Now if a transaction Ti issues a write X operation, then operation can be either rejected or operation can be executed. If timestamp of Ti transaction is less than the read timestamp of data item X, then the operation will be rejected. If the timestamp of Ti transaction is less than the write timestamp of data item X, then operation will be rejected and the transaction will be rolled back. If not, the operation will be executed. Next in our sessions we will understand about the components and the architecture of a DBMS. Thank you.